So I'm going to focus on the procedure and kind of the format of how our Technote is currently laid out. This session was inspired by a Technote being drafted by 239F, Sustainability of UHPC. A shameless plug, if anyone is involved in the sustainability committee or community, the UHPC community, you have interest, you have things you think you can contribute, join our committee, contribute, help us get this published. We have a lot more we want to do. Easy one. Yes, UHPC can be a sustainable building solution. The question is, can it? I'm here to tell you yes. But what I really want to talk about is how we came to that conclusion. Sustainability is accomplished by ingenuity and engineering mechanics. What do I mean by that? Well, UHPC, people say, oh, it's got too much binder. There's a lot of CO2 in it. It can't be sustainable. Well, the way that it's sustainable, or any other building material is sustainable, is by intelligent and informed decisions made by engineers, by specifiers, by owners, by architects. Picking the best material for the application positively impacts the built environment. So what's our goal in this Technote? We want to educate the industry, but we're going to provide a curated framework. In sustainability, there's ISO standards, there's product category rules, there's all kinds of framework that's out there that is still catching up even for conventional concrete. Now insert UHPC, which does not fit within your standard frame. We're trying to provide some insight on the appropriate assumptions to make, what rules apply and don't apply, what you should be looking for. We're going to discuss some reasonable assumptions, address common misconceptions and missteps. The easiest one, as an example, is if you pull an EPD of concrete and you pull an EPD of steel, and you say, well, steel has 10 times more CO2 in it than concrete. Oh, wait a minute, steel was per metric ton. I'll convert it to cubic yard. Now it's the same measure, and now concrete is 30 times more sustainable than steel. Well, wrong. You're comparing apples and potatoes. We're going to try and help avoid some of those things. We're going to try and demystify some case studies. The UHPC community is very lucky to have a lot of effort, energy, and money coming in from the academia side. Lots of case studies, lots of good work been done that proves that UHPC can be a sustainable and good solution. But every one of those case studies is subject to a whole slew of assumptions because there is not a standard framework for UHPC and sustainability analysis. Most importantly, this is the one I want to focus on. What we're trying to accomplish is facilitating better decision-making on sustainability. We're going to answer all of the technical questions. No, we're not. Strike that. It's 3,500 words. This is a complicated topic. It couldn't possibly be done within 7 pages. So that is not our goal, to answer everything. We're trying to give you the tools to make better decisions. And we're trying to prove that UHPC is always the best answer. Wrong again. Big UHPC believer. I love UHPC. If I stand up here and tell you it's the best thing ever and you should use it everywhere, you're not going to believe me, and it wouldn't be true. What we're trying to focus on is how you can look at your application and determine if UHPC is the right solution. So how can we prove it? We start off, we address the question, the simple one, can UHPC be a sustainable building solution? We offer a little bit of background on UHPC, but if you're trying to figure out what UHPC is, this is not going to solve all of that for you. There are other tech notes, other documents that get into more information. This gives you a high-level understanding of what UHPC is and specifically what it is through the lens of this document. Then we introduce some key definitions. This is not even the start of the surface of all of the definitions and the acronyms of the alphabet soup that is sustainability. It's just a few core ones that need to be understood to be able to process the document. Then we give you a curated discussion to address the process. We try to walk through each of the steps and how you can make the assumptions, how you can proceed, and some common things that you might find in those case studies. We'll go into guidance on the sustainability analysis. Again, 3,500 words, 7 pages. We can't walk you through a whole calculation, but we can walk you through the process and the high-level decision-making. And then we have some selected case studies at the end, which conveniently happen to prove the point, but have also passed muster. They've been reviewed. We believe they made appropriate assumptions, and they'd be a good example. So now we'll talk about what that process is. And so the way it's laid out right now, to be determined if tackle, let it stay that way, we asked a series of guiding questions. Can an EPD be generated for UHPC using the conventional concrete PCR? And I'm not going to answer every single one of these questions. I'll give some little nuggets. What I really want everyone to understand now is how we're trying to tackle it, so you can provide us feedback if you think that would be a useful document for you. So let's say the answer is yes, you can generate an EPD. Can a UHPC EPD be compared to conventional concrete EPD? And if not, how come? How do current standards, trailing behind, how do current standards of sustainable products and how that's determined impact the analysis we're talking about? What do the governing bodies determine is a sustainable product? When we say it's sustainable, are we meeting that definition or are we setting our own? In my opinion, probably the most important thing we want people to understand, which is not truly ours to define, but we're trying to help, is declared units versus functional units. The functional unit is the key to the process we're going to talk about in this document. And so we'll talk about how to compare functional units. When you set your functional unit, how do you compare it? How do you level it and make sure you're accounting for everything on both sides of the aisle? And then how do I determine limits of analysis? If my functional unit, let's say, includes the bearings because the bearings are reduced by an efficient design, where do I stop? Do I consider the whole entire bridge? Well, now I have to design the whole bridge twice. And I really want people to understand that this is the state-of-the-art guidance, but we need to acknowledge what the state-of-the-art is. Sustainability analysis is not complete. The industry is scrambling to catch up to our goals. We can't properly do this in that space if we don't acknowledge what is well-suited, what is not ready, where are the holes, what do we need to fill. So we try to talk at a very high level, very quickly, about what some of the standards cover and what's not covered, what we do and what we don't know. A good example, we do not have the answers for the end-of-life phase. We can make educated guesses, assumptions, but we don't have the answers. And the best way for us to address that is to acknowledge it, not to answer the questions that we can't answer. What we can and can't qualify, and then we go through the steps. We break it down with some curated questions at cradle to gate. And so that is a common EPD time frame. Hopefully, if someone reads this Technote, what they will gather is you can have an EPD with an LCA. If you have an EPD, you already had an LCA. You can have an LCA without an EPD. We'll address A1 through A3. What does that mean? We'll address A1 through A5. Is that covered? We'll talk a lot about the use phase. Use phase is really where UHPC gets interesting. It really starts to have high rate of return. And then again, we'll address end of life, because if we're going to push whole life and a holistic approach, at a bare minimum, we need to acknowledge it or qualify why we stop or truncate our analysis. And so I want to conclude, what will the reader gain? Yes, UHPC can be a sustainable choice. Understand the high-level state of the industry. You'll understand where some of the gaps are, some things that are maybe a little bit more of a reach in your engineering judgment, and some things that are really well-defined in black and white and standardized by ISO or whoever the body is. You'll understand what an EPD is and maybe some things, what it's not. You'll understand that you can have an LCA without an EPD. We'll talk about some other tools or assumptions. You will understand functional units, and I can't emphasize enough, that is going to be the most important takeaway. The way that UHPC gets looked at through the appropriate lens to be sustainable is a functional unit, looking at a bridge girder instead of a cubic yard. That is how you apply your engineering mechanics and ingenuity to make this material be sustainable. And then we'll prove it. We'll give you a whole table of some high-value, well-vetted case studies, and that'll be enough to kind of get you on your way. Reading this case study is intended to put you in the right direction, to ask the right questions, to go looking at the right documents if you really want to understand the alphabet soup, or if you want to understand what types of structures were designed more efficiently, and go to references. So all we're really trying to do is be an interchange, but point you in the right direction in that interchange. And now I will hand it off to Zach. Kai? Thank you.